represented it using that formula. But it's this chain with an H. So in other words, the H2 reacts with this guy here to regenerate the catalytically active species and the product. How? Well, there's two and only two ways that that can happen. What are those two and only, well, actually there's more than only two and only two ways, but the two and only two ways that we've looked at could be what? You said it, Nicole. Oxidative addition. Yes, but there was another alternative. Well, if you got beta hydride elimination, you'd end up with a weird system that has a C double bond O, C double bond C. So no, it doesn't undergo beta hydride elimination, but in principle it could. But let's figure this out. As a matter of fact, this, the actual details of this last step, which is the rate determining step in this cycle, has been heavily speculated in the literature. That's why I want us to discuss it. Let's just call this R. All right? Just allow me to call it R if I may. Now, if this reacts with hydrogen, what's going to happen? Two possible things. The first could be oxidative addition. So I could get something like this, right? Now, what would the oxidation state of that intermediate be, of the cobalt? +3, so that's perfectly allowed. Okay, and then we could have classic reductive elimination of that guy, and we form our products. We regenerate the cobalt CO4H, closing the cycle, and this guy. That's a possibility. Why is that problematic, though?
Well, because you could also reductively eliminate in a different way, right?
How?
With the other things?
With?
With the kind of carbon dioxide.
No, because these are neutral. Remember, you only get reductive elimination with anionic ligands, alkyl, hydride, etc.
Or you could just make hydrogen gas.
Well, of course, all these processes are in equilibrium, right? Back and forth, back and forth. You can see the equilibrium arrows. This process, however, is not in equilibrium. It goes like a bomb, okay? But in principle, yeah, most of the time in these catalyst cycles, you have backwards, forwards, backwards, forwards. This is the rate determining step. So actually, once it's over that hill, it goes down to the product. Why is that problematic? Well, it's a 7-coordinate system. Now, that's not really a problem per se, because hydrogen is very small, and that shouldn't be too much of a problem. So I would say that that is a possibility, right? That it goes via a formal oxidative addition reductive elimination pathway, and some scientists think this. There is, however, another school of thought that thinks that it goes via a concerted mechanism involving sigma bond metathesis. Remember what sigma bond metathesis is? What is it? Sigma bond metathesis is something like this. And we said, more or less, that sigma bond metathesis is very common with early transition metals and lanthanide complexes. Now, it's possible that we have sigma bond metathesis going on for this guy, so let's redraw this intermediate. So the acyl. Now, what could actually happen here? Well, we can have sigma bond metathesis going on. So something like this. Wait a minute. I need to, let me just draw it on the side, because let's draw this guy on the side so we can see it. So we could have something like this. Sigma bond metabolisms. It's fundamentally, you see, it's fundamentally a completely different process to oxidative addition, reductive elimination. It's a concerted mechanism. It doesn't change the oxidation state of the cobalt. That's the cardinal difference. And this will also afford the desired products. So there is some speculation in the literature as to which it is. Scientists have done a lot of studies on this, and there is some evidence for both. But the fact of the matter is that the reaction proceeds, that is the rate determining step in the case of cobalt. It proceeds very rapidly, and we end up with a product. Now, what I haven't looked at all in this cycle is whether we end up with the N, in other words, the normal chain with a carbonyl sitting at the end, or if we end up with iso. Remember, we have the possibility, because we've got a double bond, that either the carbonyl sits at the one carbon or the other. And I think that's just something for next week. In terms of the midterm, I want us to be able to, we're going to go up until the end of this cycle, right? So basically slide number, what is the slide number? Whatever. Up until the end of this cycle. Next week we're going to continue with this, and we're going to look at this in a little bit more detail. Are there any questions? Anything at all? No questions? All right, see you guys in a tutorial later.